Homework 20, hypothesis test for mu, sigma known, video 1. In the previous series of videos, we discussed the basic concepts of hypothesis testing, what a null hypothesis was and an alternative hypothesis was, what type of test was dictated by the alternative hypothesis, how to state a conclusion, how to identify a type 1 and a type 2 error. In this series of videos, we're actually going to perform a hypothesis test specifically for population mean. In other words, if somebody makes a claim about a population's average and we have sample that provides evidence to the contrary, how do we proceed to determine whether or not the sample is sufficient enough evidence to reject the null hypothesis, or if it's not sufficient enough evidence and as a consequence we do not reject a null hypothesis. Just remember, when we reject a null hypothesis, that doesn't necessarily mean it's false. It's possible it could be true. That's a type 1 error. And when we do not reject the null hypothesis, that doesn't mean it's true. It's possible it could be false. In that case, we committed a type 2 error. But before we get into the details on how to actually conduct a hypothesis test, I want to introduce you to an important concept called a significance level. The significance level, which is whose variable is the Greek letter alpha, lowercase alpha, is the probability we use to determine if a sample statistic is unlikely, assuming that the null hypothesis is true. Now, we've seen the word unlikely before in terms of probability. In fact, one of the questions on one of your tests was an event is unlikely if its probability is less than something, and the answer was 5%. In general, we're going to use a significance level of 5%, but there are certain cases where you may want to raise the significance level. After I draw this picture, I'll explain a case where you would want to do that. I hope I remember I just said that. For example, let's consider this pair of hypotheses. Somebody complains. Somebody suggests that the mean of a population is 50, whereas evidence suggests in the alternative hypothesis, no, we think the mean is less than 50. If alpha equals 5%, determine the critical value for the test. Now, what do I mean by that? Well, the significance level goes hand in hand with the type of test. For example, in this alternative hypothesis, because it says greater than, did I say less than a minute ago? Regardless, it says greater than, then this is going to be a right tail test. As you'll see in a moment, in one of the steps in conducting this hypothesis test, in fact it will be the second step, you will draw a bell curve. In fact, it will be a standard normal distribution, so this will be a z-axis. And the type of test tells you which tails to shade in. In this case, a right tail test means we're going to shade in a right tail. Remember in the previous series of videos, what we're attempting to find out is when is a sample so far off the middle that it's far enough away to say, I have enough evidence to reject my claim about the population. The answer is if it lands over here. But where is over there? How much area is over here? That's what the significance level represents. The significance level visually is the area of the tail or tails that you cut off based on the alternative hypothesis. So the area here would be 5%, which as a decimal, of course, is 0.05, but because you know I'm about to go into the z-chart, we'll put a couple of zeros on there. So if we were to look up 0.0500 in the z-chart, I know some of you are thinking, but that's the right area, not the left. I'm aware. If we go to find 0.0500 in the chart, if you have your chart handy, go to the negative 1.6 row. And as you go across the negative 1.6 row, you will see 0.0505 and 0.0495. So again, in the z-chart, in the negative 1.6 row, go across, you'll find 0.0505 and 0.0495. The 0.505 is in the 0.004 column. Excuse me, the 0.04 column. And the 0.0495 is in the 0.05 column. So to find the z-score that we're looking for, the area we want is dead center between these. It is exactly 5 ten-thousandths below this and 5 ten-thousandths above that, this decimal. In the event that your area is dead center, I always default to the larger of the two. Now, somebody had expressed concern in one of their homework questions that they did that, or at least they think they did that, and it counted the answer wrong. On your test, I will review every answer, every wrong answer, and if it counts it wrong because of oops, I picked the wrong number up here, or you picked one other than what they were expecting, I would give you full credit for that problem. But I digress. Because the area we're looking for is dead center between these, we're going to default to the larger digit up top, which means we're going to use this area, which means the z we're looking for is negative 1.65, except it's not. Why? Because the z's on the right are positive. Remember, this tells you left area. We were looking at right area. The ways to account for that are either calculate the left area by subtracting this from 1 and then looking it up, or keep in mind that you're looking on the incorrect side, so when you find the z, it's the wrong sign. But regardless, it's going to be 1.65. So what we're going to be doing with the significance level in every hypothesis test is setting up a bell curve, cutting off a right tail, left tail, or two tails, depending upon the sign in the alternative hypothesis. And then the significance level will represent the area of those tails. Then we use the z-chart to figure out what z separates the tail from the rest of the curve. The value that separates the tail from the rest of the curve is called the critical value. It was called that in confidence intervals as well. One more thing about terminology. The part that you shade in, the author refers to as the critical region. Meaning, if you have a sample that lands over there, we have sufficient evidence to reject your null hypothesis. In some textbooks, this is called the rejection region, because the decision we will make is reject the null hypothesis. In those textbooks that call the critical region the rejection region, the part over here is called the non-rejection region. We'll do one more example of transforming a significance level into critical values to separate critical regions from the rest of the curve before we get into the procedure for conducting a hypothesis test.